Okay, today's the first day of Chapter 5, so you're going to need a new divider in your binder, and Chapter 5 is all about linear functions. Most of the stuff that you're going to see in this chapter is review from middle school, but we are going to add some different types of problems and make them a little bit more complicated than the ones you saw in middle school. So for today, we're talking about rate of change and slope. And remember that rate of change shows the relationship between two changing quantities. When one depends on the other, the following is true. The rate of change is the change in the dependent variable over the change in the independent variable. You guys know it as delta y over delta x, change in y over change in x. So what we're going to do today is we're going to look at rate of change three ways. We're going to look at using a table, using a graph, and using a set of ordered pairs. So we're going to start off finding a rate of change using a table. The table below shows the distance a marching band travels over time. Is the rate of change in distance with respect to time constant? So we're going to look at the rate of change, or the change in y, over the change in x to get our rate of change. So to go from 260 to 520, I have to add 260. To go from 520 to 780, I add 260. And to go from 780 to 240, I add 260. Now be careful, because you want to make sure you check all the values and make sure you're careful with that, because they do like to do stuff. Well, they'll give you the two changes are 260 and then make the third one a different number, or even the fourth one a different number. So the change in y is 260. Then we look at the change in x, and each x value is going up by 1 each time. So the change in x is 1, making the change, the rate of change 260. So is the rate of change in distance with respect to time constant? Yes, the rate of change is constant. Each change in y over change in x, we always got 260. Okay, part A, what does the rate of change mean in the context of the problem? Now, this is what you're going to see quite a lot this year. Last year, you used to just find the rate of change and you would be done. But now we have to find it in the context of the problem, meaning that we have to use words like minutes in feet, or time in distance in our explanation. So if we think about what 260 means for this problem, we can say that for each minute, the band marches 260 feet. Or you can simply say something like the band marches 260 feet per minute. You have to use the words in the problem when you're writing in the context of the problem. Okay, part B, do you get the same rate of change if you use non-consecutive rows in the table? So for example, when I found the first rate of change, I went from row 1 to row 2 to row 3 to row 4. But this question is asking if I use non-consecutive rows that are not in a row. So if I went from 1 all the way to 4, and then from 260 all the way to 1040. So if I found my change in y over change in x, using 260 and 1040, using the first and last rows, I would say that the change between 260 and 1040 is 780. And the change in x to go from 1 to 4, I'm changing by 3. So 280 divided by 3 is also 260. So is the rate of change the same using non-consecutive rows? Yes, because the rate of change will always be 260. Because it's constant. So no matter what rows we look at when I do change in y over change in x, I'm always going to get 260. Okay, next question, number 2. Is the rate of change in cost with respect to the number of pencils bought, is it constant? And then explain your answer. So again, we want to find the rate of change. We're going to look at change in y over change in x. So to go from 0.25 to 1, I have to increase by 0.75. To go from 1 to 1.75, I increase by 0.75. But to go from 1.75 to 3, I have to increase by 1.25. And some of you will stop there and say, oh no, the rate of change isn't constant, but you're forgetting that you have to do change in y over change in x. The x's from 1 to 4 change by 3, from 4 to 7 change by 3, but from 7 to 12 they change by 5. So it looks like the y's aren't going up by the same number, and neither are the x's. But again, that still doesn't mean that the rate of change isn't constant. If I look at the change in y, 0.75, over the change in x, 3, I'm going to get 0.25. But if I change it and look at the last two columns, the change in y is 1.25, and the change in x is 5, which also gives me 0.25. So yes, the rate of change is constant, because I'm always paying 25 cents per pencil. Okay. So when we're looking at tables, in order to find change in y over change in x, you can do y2 minus y1 over x2 minus x1, or just look at the changes in the y's over the change in x. Now what we're going to do is look at slope using a graph. The graph of the ordered pairs, time and distance in problem 1 lie on a line as shown below. The relationship between the time and distance is linear. Remember, if the data is linear, the rate of change is constant. We talked about that in chapter 1. When I had you determine if functions were linear or nonlinear, we looked at the rate of change. All linear functions have a constant rate of change. Notice that the rate of change is just the ratio of the vertical change, meaning the change in y's, up and down, to the horizontal change, meaning the change in x's, side to side. So we call that the vertical change over the horizontal change, which is rise over run. This rate of change is also called slope. So slope is rate of change, it's rise over run, it is also the change in y over the change in x. So now we're going to practice finding the slope using graphs. Remember that slope, we also used the variable m to represent slope. So m equals rise over run. So when you're looking for slope on a graph, you're going to pick two nice points, any points on the line you want, as long as they hit those grid lines. And you're going to look at the rise. You're going to go up 2, and then you're going to run 1, 2, 3, 4, 5. So the rate of change is 2 over 5, or the slope is 2 over 5. Keep in mind you have to give me reduced fractions when you're looking for slope. Okay, for part B, m is equal to rise over run. Again, pick any two nice points. It doesn't matter what points you pick, as long as they're on the grid lines. You're going to do rise. In this case, I'm rising 2, but I didn't run anywhere. I don't have a run going left or right. There is no horizontal change. And if you put 2 divided by 0 in your calculator, you're going to get an error because you are not allowed to divide by 0. So this slope is called undefined. It's an undefined slope. If you look at it, part B isn't even a function because it doesn't pass the vertical line test. There are multiple x values that go to the same y value, or the x values repeat for different y values, so it's not a function, therefore the slope is undefined. In part C, again we're going to do rise over run. They already picked two nice points on the graph for us. To get from one point to the next, I have to rise nowhere, and I run 1, 2, 3, 4, 5. If I were to put 0 divided by 5 in my calculator, I'm going to get an answer because I'm not dividing by 0, I'm dividing actually by 5. So the slope of this line is 0. Think about how much steepness there is. There is no steepness to this line, so the slope is equal to 0. And then in D, again, we're going to find the slope as rise over run. They have two nice points marked for us. So to get from one point to the other, I'm going to rise 2, but then I'm going to go to the left in the negative direction 6 spaces. So it's going to be a run of -6, which is going to reduce to -1 over 3. That negative sign can be in the numerator, denominator, or right in front of the entire fraction, because keep in mind that a positive divided by a negative is always a negative number. Okay, so to wrap up slope with graphs, a line that is going uphill is always going to have a positive slope. A line that is going downhill is going to have a negative slope. A line that is completely flat is going to have a 0 slope, and a line that is completely vertical or up and down is going to have an undefined slope. So make sure you remember those. It'll help you when you're finding slope. Okay, now we're going to find slope using 2 points, which again you did last year. So when you have to find slope using 2 points, you're going to use the slope formula, y2 minus y1 over x2 minus x1, which remember is y, but it is still the change in y over the change in x, or the rise over run. It's all the same thing. Now, you've been doing slope formula for a while. I just want to make sure you don't do any stupid mistakes like not paying attention to your signs or not paying attention to the order of the variables. So make sure you label your ordered pairs as x1, y1, x2, y2. So if I want to find the slope of the line through -1, 0 and 3, -2, I'm going to do y2 minus y1 over x2 minus x1. The second y is -2, the first y is 0, the second x is 3 minus the first x, which is -1. Watch your signs when you're finding slope. -2 minus 0 is -2, 3 minus a -1 is 4, and make sure you reduce that value to -1/2. Again, watch your signs, make sure you give me reduced fractions. Okay, the second one. What is the slope of the line through 1, 3, x1, y1, and 4, -1, x2, y2? So to find the slope, we're going to do y2 minus y1 over x2 minus x1. The second y is -1, the first y is 3, over the second y is 4, the second x is 4, minus 1, which is the first x. -1 minus 3 is -4, 4 minus 1 is 3, so the slope is -4 over 3. Okay, and then the last one, what is the slope of the line through 4, -3, and 4, 2? Remember to label x1, y1, and x2, y2. So subbing into the formula, we're going to get 2 minus a -3 over 4 minus 4. 2 minus -3 is 5. 4 minus 4 is 0. Again, if you're not sure if that's supposed to be undefined or 0, put it in your graphing calculator. But remember, you are not allowed to divide by 0, so you're going to have an undefined slope. Okay, for your homework, make sure you are only doing the even numbered problems, 10, 12, 14, 16, 18. Do not do all of them. Make sure you do number 39. You should be able to get your homework finished quickly.